Hey there, everybody. Welcome back. We're going to continue 2.5, which is on absolute value equations and inequalities. We are going to do the inequalities now. Okay. So there's two outcomes that we can get. We can have the absolute value of x is less than 3, or like less than a. Let's go with a. Or less than or equal to. The other option or outcome would be absolute value is greater than or greater than or equal to a. So if we explore these, if I do x is less than a or x negative a, when you do the -1, you have to flip the sign. So that's going to happen on both of these. Flip the sign makes it like that. That's the important part. Because remember, what this is doing, the way this is really written is absolute value of x equals x if x is greater than 0, or negative x if x is less than 0. So when I have absolute value of x equals a, if we do the x is greater than 0, it just stays positive. Sorry, let's put the less than back in. And then I could do the other one. I have negative x is less than negative a. Nope, positive a. The right side is staying the same. And then when I divide by the -1, I have to flip the sign. So that's where I get the sign flip. So this one's up there, and those are the same. You'll notice on this one, though, absolute value of x less than a, I have x is greater than negative a, or x is less than a. I could change the order of these. And now I can put them together to make the sandwich. So the absolute value, the less than turns into a sandwich. Or as I like to say, a sandwich. Can I do that with the greater than one? I have x. If I put these in the same order, I would have negative a is greater than x, or x is greater than a. And if I try to sandwich these together, I have negative a is greater than x, which is greater than a. But just ignore the middle spot for a second. If I ignore the x, I'm saying that negative a is greater than a. That condenses down to negative a is greater than a, which is false. So no sandwich for the greater than or equal to. Just the less than equal to. Can we make the sandwich? So that might be an easy way to remember it. Absolute value x, or variable expression. less than a, we do the sandwich. And if we have x or variable expression is greater than a, you have to do it as both. X is greater than a or x is less than negative a. That's the basic, what all that last page boils down to. I was just showing you why it's true. Okay, so with that in mind, let's crash through some problems. Let's start off with our first example, just to make it nice and simple. X plus 2 in absolute value signs is greater than 4. I can split it to x plus 2 is greater than 4 or x plus 2 is less than negative 4. Remember, you got to change the sign when you do the negative version. I solve. I get x is greater than 2 or x is less than negative 6. Greater than 2 is going that way. Negative 6 is going to the left. 2 is going to the right. So we have, this is a union outcome. Negative infinity to negative 6 in union with 2 to infinity. Right? We'll kick it up a notch. 3 times the absolute value of 2 minus x is less than or equal to 27. We divide by 3 when we get the absolute value by so now I have 2 minus x is less than or equal to 9, or 2 minus x is greater than or equal to negative 9. Subtract 2, I get negative x is less than or equal to 7. Divide by negative 1, and I have to flip the inequality. Divide by negative 1, I have x is less than or equal to 11. So if we put it into a sandwich, it's negative 7 is less than or equal to x, less than or equal to 11. And in interval notation, we have negative 7 to 11 in brackets. Another way of doing this, the absolute value of 2 minus x is the same thing as the absolute value of negative 1 times x minus 2. And that equals the absolute value of negative 1 times the absolute value of x minus 2. But that's just positive 1. So I could have done x minus 2 is less than or equal to 9. And you'll see we would have gotten the same things. Add 2, I get x is less than or equal to 11. Or add 2 here, and I get x is greater than or equal to negative 7. So we got the same thing either way. If you stick with the normal path, you can't go wrong. All right. What about absolute value of 8x minus 5? And then we're going to have plus 12 is greater than 20 or less than 20. Go ahead and pause it and try to work this out and see what you get. All right, I will assume you did. 8x minus 5, the absolute value is less than 8 after subtract 12. And now we split it. And do less than the positive or greater than the negative. And we solve each of these individually. 8x is less than 13. X is less than 13/8. Add 5. Where x is greater than negative 3/8. Another way of doing this, when you have less than, you can do it like this. Since we know the answer is a sandwich, we can do a sandwich, which is what I had listed above. But I want to show that we're going to get the same thing either way. Right here, I had it listed as a sandwich here. I wasn't doing the sandwich, but now I'm going to. Where I add 5 before, I need to add it to all regions. Divide by 8 everywhere. I get negative 3/8 is less than x, which is less than 13/8. If I put these in order, I have negative 3/8 is less than x, and then I had x is less than 13/8. I got the same thing either way. Sandwich or no sandwich. So interval notation would be negative 3/8 to 13/8. And it's filling it in between those two. Got a few more. Need to adjust myself. Next one. 10 minus the absolute value of 2x minus 5 is less than or equal to 6. Pause it and try solving it, please. All right. Subtract 10. Absolute value of 2x minus 5, and then a negative on it, is less than or equal to negative 4. If I divide by negative 1, I have to flip the inequality. And now I don't have a sandwich. I have a split situation. 2x minus 5 is greater than 4, or 2x minus 5 is less than or equal to negative 4. 2x is greater than or equal to 9. X is greater than or equal to 9/2. Or we do the negative version. 2x is less than or equal to 1. X is less than or equal to 1/2. Nine halves is 4.5. 1/2 is 0.5. So we're looking at right here and right here. Greater than 4.5 is to the right, and we fill in the bubble. Less than 1/2 is to the left, and we fill in the bubble. So here we have a compound inequality with the union. Brackets on the 1/2 and the 9/2. But everything else goes normally there. All right, so what happens if we have the absolute value of 2x minus 6 is less than 0? This one is tricky. You try to keep it the same and do the opposite. It doesn't make much sense. And this should be an and because it makes a sandwich. So I have 2x is less than 6. Divide by 2 and I get x is less than 3. And x is greater than 3. X is less than 3 is that, and x is greater than 3 is that. There's no overlap. The reason why, remember, this is distance from 0. Distance has to be greater than 0. And there's no way to get a number less than 0 here. So there's no solution. That's going to be same thing, even if it's like 2x minus 6 is less than negative 10. Same problem. Same problem, no solution. So be alert for inequalities where it's less than 0. The absolute value is less than 0. It doesn't work. Something else to be alert for? Again, this is a distance, which means it's greater than 0. And 0 is greater than negative 1. So no matter what's in here, this is going to work. The greater than is an or situation. We're going to get all real numbers here. And I'm going to show you working it out that it works that way with the or. 39x minus 97 is greater than negative 1, or 39x minus 97 is less than 1. Now I'm wishing I hadn't used such big numbers. So x is greater than 98 over 39. Or x is less than 99 over 39. $2.51. $513. If I just do 2 decimal place or 1 decimal, shit, I only need 1 decimal place, right? I think I got that first number wrong. I do. That's 2.51. All right, so if I do a number line, I've got 2.50, 2.51, 2.52, 2.53, onward. Greater than the 2.51 is that way, and less than 2.5 this way is this way, but it's an or situation, so it's not the overlap. So we'll see that it's all real numbers. So less than a negative or greater than a negative either yields no solution or all numbers. something to be on the lookout for, absolute values. That's it for chapter 2. Peace.